All right. Okay. Now let's start. All right. Now this is what we are going to do today, guys. We are going to do a very important session, right? All right. Now today we have to do unit 3. Okay, unit 3 is our target. Okay, we have to do unit 3. Right. Now in unit 3, a minute, guys. Right. First of all, online students, you all can hear me, right? Can chat. Put a chat. Can you all hear me clearly? Yes, no, what? Yes. All right, good. Now, okay. Now, first of all, unit 2, we have a small bit like for like 45 minutes part talk, we have a small thing. Finally, we have to speak about electronegativity, right? That's a very small part actually. Now, now we are starting today, October 1st, Children's Day, no? Right? You all children? All right. Then, okay, then happy Children's Day, first of all. Okay, so tell thank you. Right, okay. Then, okay, first, then from children, you are in the last stage of your childhood. After that, you are not anymore children, it was say. Right? In case you go to university, still, you can be children again. Right? Anyhow, so you are in the last stage, guys, in your childhood. So this is your final stage where you have to decide. You are going to decide your life paths for different stages, right? Now itself, after O levels itself, you have gone for different paths, but still you are not fixed into it, right? So whatever you are performing now, it's going to completely decide what you're going to be, right? So it's a very important thing. Okay, therefore, every single dedication, every single thing what you're doing now matters in future, right? Remember that part. Okay, all right. Then so this is the thing. So you are coming for unit 3, guys. When you come to unit 3, okay, when we come to unit 3, now today is unit 3. Unit 3, actually, when you take this as a single unit, you will get around 3 MCQs for this. For unit 3, you will get around 3 MCQs in the MCQ paper. 3 MCQs. And you will have a chemical calculation question using this. Where you're going to get around, again, you need the help of not inorganic chemistry as well. But with the inorganic chemistry, we'll say if you are getting, normally they have allocated 75 marks for this. 75 marks mean if you divide by 20, 75 divided by again 20. 75 divided by 20 is how much? 3 point 3 point 3.75. Right? 3.75. You have 3.75 marks. There are 3.75 mean out of that 3.75 they have allocated in this one, but you need inorganic support as well, but we'll take 3.75. Right? Then finally, This 3 and 3.75 together, you get 6.75 marks in the paper. 6.75 is a very good marks when you take the uh, chemistry paper. 6.75 only from this lesson. Plus, this lesson is important for all the physical chemistry lessons. Right? This lesson is important for all the physical chemistry lessons. Right? They'll say if you can't do this, mean you can't do physical chemistry. So if you can't do physical chemistry, if you are unable to do this one properly, Buddha, nearly you are going to lose 25 marks in the full paper with this 6.75. And if you can't do this, nearly you are going to lose 31.75 marks in the paper. Right? So understand how important it is. Right? 31.75 mean, can you tell me you can't go for A. Right? You can't go for A. Even can't go for B without this. Right? Again, finally, you have to stop your journey in the middle. And also mostly, there is a thing like this in this unit. Most of the time, like mostly, like 99% of the students can't do this lesson at once. The initial thing itself, they can't be a very good performer in this lesson, right? With the time being only, you will be good performers when we are practicing lots of questions in this lesson. Normally, this is the lesson. Everyone get confused. Everyone going to get like going to have a bad, a horrible lesson. Mean it's unit 3 because you are not that matured enough to face this unit, but still fine. Okay, we have to do this. Without this, we can't start up the other lessons because this is the basic part of all the lessons, right? So don't worry, I will do my maximum to put everything very smoothly. But the main thing is your practice, right? So hereafter we'll have our class as usual. Again, like at 3:30 to 7 o'clock. We have planned that. Okay, until I inform, we'll go like that. Okay, if there are any changes, we'll see after that. Now, 3:30 to 7, we will go, right? So this is the first of all, you should understand the importance of unit 3, right? Now, first of all, first write unit 3. First write the heading unit 3. Okay, unit 3, chemical calculations. Unit 3, chemical calculations. First of all, we'll write the note. Mainly, I love to write notes. Okay, after that, after once the lesson is done, we'll give a short note on this lesson, right? The main thing, you have to write everything on your own. Right, unit 3. For the practice questions, I will give you some tunes. For the time being, now start with unit 3, chemical calculation. Okay, good. Under chemical calculation, Putha, under chemical calculation, first of all, we'll speak about oxidation numbers. Topic is oxidation numbers. Right, under chemical calculation, the topic is oxidation numbers. Oxidation number. This is the topic. Already, I told you a small thing about oxidation number in unit 1, right? To fill that table, but now we'll speak deeply on this oxidation number. All right. Now, on the oxidation number, there are a few points to remember. Very easy, actually. Very easy. But carefully see this part. Okay. Okay. But are you okay with that, please? Climate control, fine. Right. Now, on the oxidation number, Putha, the first point you have to remember, the first thing you have to remember is, right, oxidation number of elements. Oxidation number of elements. Okay. Elements, oxidation number. Elements, oxidation number. Elements, oxidation number is 0. Elements oxidation number is 0. If you take elements, those oxidation number is 0. So if they tell any element, for an example, if they say sulfur, if they ask what is the oxidation number of sulfur, answer is 0. If they ask what is the oxidation number of chlorine, then the answer is 0. What is the oxidation number of fluorine? Answer is 0. Any element, the elemental state, the oxidation number is 0. All right. And okay, elements oxidation number is 0. Then when you take O2, what is the O2's oxidation number? Is O2 an element? Yes, right. O2 also comes belongs to element. Then what is the oxidation number of oxygen? 0. What is the oxidation number of ozone? Answer is 0. What is the oxidation number of S8? S8 is 0. You can normally sulfur present as S8. S8 means there is a normal sulfur present like S8. So S8 is 0. All these things, so whenever they ask elemental form, they are 0. You got the point? Okay. These are some examples for this. Okay. These are some examples. Right. And other thing is, the second thing you should know. Okay. Compounds. Compounds. Oxidation number. Compounds. Oxidation number. Okay. Compounds. Oxidation number. What is compounds oxidation number? Compounds oxidation number is how much? Compounds oxidation number also 0. Okay, compounds oxidation number is 0. For an example, if they ask what is the oxidation number of CO2, CO2 equal to oxidation number is 0. We'll say, okay, NO2 oxidation number is 0. We'll say sodium chloride. What is the oxidation number? 0. Any compounds oxidation number is 0. Okay, any compounds oxidation number is 0. But here I have to put a point from red color. Okay. Although the compounds oxidation number, although the compounds oxidation number is 0, although the compounds oxidation number is 0, each element in the compound have have different have different oxidation numbers, have different oxidation numbers. Right. Yeah, although the compound oxidation number is 0, each element in the compound have different oxidation numbers. We'll see how to see that. Now, at the moment, you should know this. When you take a compound, that oxidation number is 0. Right. Third point. Right. Third point. Point number 3. First of all, we'll write the note. Once you're done with the note and when I'm showing the examples, you will understand everything accurately. Okay. We'll write the third point like this, Puta. Third point. Ions oxidation number is equal to the charge of the ion, is equal to the charge of the ion, is equal to the charge of the ion. Okay, what does it mean? It means will you take Fe2 plus, what is the charge, that is the oxidation number of this, plus 2. Fe2 plus means oxidation number is plus 2. For an example, we will say CO3 2 minus, then what is the oxidation number of this? Minus 2. CO3 2 minus. We'll think a PO4 3 minus. What is the oxidation number of the ion? Minus 3. Okay. 3 minus 3 minus 3. So whatever the charge they are having, that is equal to the oxidation number. Got the point? Right. But here also we can say, although the same sentence I can put here. The same sentence, whatever the sentence I have written here. The same sentence I can put here. Although the, but here I can't say compounds. I have to say, instead of compounds, I have to say ions. Although the ions oxidation number is, here I can tell 0, is equal to their charge. I'll take this one. is equal is equal to their charge is equal to their charge is equal to the charge is equal to the charge. Each ion, each element in the ion, each element in the ion, each element in the ion have different oxidation numbers. So you have to remember this. But when I'm telling these things, sometimes you want much familiar for this. Till when I'm doing the questions, you will understand that, right? Okay. So this thing is the other one. Okay. Right. So these are the things we have to know. Another one, you can another point in a compound. Okay, in a compound, you can say in a compound, no, in a compound, no, we'll say most electronegative, okay, most electronegative most electronegative element will have will have a minus charge, will have a minus charge, will have a minus charge, and the other element and the other element will have will have a positive charge, will have a positive charge, right? So this is the other thing. Most electronegative element will have a negative charge and the other element will have a positive charge, right? So these are the important points, right? You should know. Okay. Now what should you do? First of all, we'll write these things. Okay. Okay. Write these things, guys. Okay. Still just an overview is just going. Okay, first of all, we'll write these things. After that, you will understand everything. Right. Now, see this. Okay. Right. Now, these things are okay. Okay, these are some important things you should know. Most electronegative element will have a negative charge and the other element will have positive charge, right? And you should know some common oxidation numbers. Common oxidation numbers. Normally, common oxidation numbers mean, Buddha, normally these are some common oxidation numbers. But if you have missed something, you write it later. Now observe here, right? Common oxidation numbers. Common oxidation numbers. Right? Common oxidation numbers. What are the common oxidation numbers we have? When you take oxygen, Buddha, normally oxygen normal. Normally oxygen mean, this O mean, normally common oxidation number is most of the places -2. I said most, mostly -2. Oxygen mostly -2. When you see oxygen, mostly it comes as -2. Whenever you see fluorine, whenever normally most of the places fluorine will get a -1. These are some common oxidation numbers, right? Alright. So this is the way how we have to put. Okay, now I will show some oxidation numbers, how to find oxidation numbers quickly. Okay. In oxygen, there are different categories. Oxides, peroxides, superoxides. There are three things. We'll come everything later. At the beginning itself, if I tell about oxides, superoxides, and peroxide, you will get a problem here. Putha, you got the message class at 3:30. Putha, did you get the message class at 3:30? Aren't you in the group? You're in the group, right? You're not in the group, right? What subject? WhatsApp change. I heard like, what's the subject? Uh, you can come here at 3:30. No problem. Directly you can come from school, I guess. Hmm? Okay. This okay, you can join this. Okay. Last week you missed the session, right? Did you cover up? You didn't request also. You don't have your WhatsApp anymore. Ah, is it? Why you lost your phone or something? Okay. Right. Fine. Okay. What? Alright. Now, okay. No problem. Today it won't affect. So far, whatever we have done also won't affect you. Right. We started oxidation numbers. Okay. So we are continuing with that. Okay. Now, just now I'm going to give the first example. And oxidation number, Buddha. Now, we'll think ammonia. Ammonia. Now I'm giving ammonia for you. And I told you one thing. What? If you take a compound, what is the oxidation number of it? Right. Come on, guys. Tetracolor. Right. Okay. What is the compound's oxidation number? Any compound's oxidation number is equal to 0. And I told the most electronegative element will get a minus charge. One is most electronegative, the less electronegative one will get the positive charge. Now ammonia is connected like this. Now you know this one. So ammonia, you just think like this. Ammonia mean what? One nitrogen is connected to three hydrogens like this. Okay, one nitrogen is connected to three hydrogen. This is only ammonia. So when you take ammonia, Puta, right? When you take ammonia, who is most electronegative here? Nitrogen. Then hydrogen is less electronegative. Then I said the most electronegative will get a minus charge. So for this bond, nitrogen will be -1. Then for one hydrogen, it should be +1. This nitrogen will be -1. This hydrogen will be +1. This nitrogen will be -1. This hydrogen will be +1. Then what is the oxidation number of nitrogen now? All three things together, -3. So I have to put -3 is the oxidation number of nitrogen. Okay. Hydrogen will be hydrogen. We can put +3. +3 for all three hydrogens. All three hydrogens only +3. Then one hydrogen atom is one hydrogen atom. What is the oxidation number? +1. Remember, normally under common oxidation numbers, normally take oxygen as -2. For fluorine and all -1. Then if you see hydrogen, normal place, mostly it is +1. Most of the places, hydrogen comes as +1. Most of the places, mostly. Now, but you have to understand, like using these structures, you can identify what is the oxidation number. This is an example for ammonia. We'll take water. Okay. Now, I said always no need to draw structures like this, guys. Right? You can think like this. Water, H2O. How can you think about the oxidation number? Why? Because the -3 and +3 altogether oxidation number is equal to how much? 0. I said no, compound oxidation number is 0. Right. When you come to H2O, if you come to H2O like this, you can see the oxidation number for this. I said normally oxygen's common oxidation number is what, Putha? -2. Then I can put -2 here. Then both the hydrogens will be, because this total should be equal to how much? 0. No? Either both the hydrogens will be +2. Likewise, you can decide the oxidation numbers. Then finally we can write, here finally you can write down nitrogen is equal to -3, hydrogen is equal to +1. Okay. Here hydrogen is equal to, one hydrogen is equal to how much? Two hydrogens are +2, one hydrogen is +1, then one oxygen is -2. Are these things clear? Now you have to be very careful for this compound. You see how you going to reply for this. We'll think you have a compound called OF2. 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 Who is the most electronegative element in this? Fluorine, right? Fluorine is the most electronegative element. No one can beat fluorine. So what's the charge what is the oxidation number go to fluorine then? Plus or minus? Minus. Then normally fluorine, I said, what is the oxidation number of fluorine? +1 or -1? -1. So fluorine is -1. Then here, how many fluorines are there? 2 fluorines. Then 2 fluorines are what? -2. First of all, always you have to put the oxidation number for most electronegative element. So this is -2 mean this oxygen should be what? And this oxygen become +2. Normally, this is the only place where you can see a +2 oxygen. Like normally oxygen, second after fluorine, most electronegative element is oxygen. So oxygen is only getting a plus charge when there is fluorine. So OF2, fluorine will never become what? Fluorine will never become plus. Fluorine will never get a plus oxidation number. Okay. That's a very important point. Fluorine never gets a plus oxidation number. Never gets a plus oxidation number. Right? Because fluorine is the most electronegative element. Right. Nice. Fluorine never gets a plus oxidation number. So those things are fine. OF2 is okay. Next one, we'll think Mm, H2S. 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 Now you just put the oxidation number for whatever you know. What you know? Sulfur you don't know. Hydrogen you know. What is hydrogen? One hydrogen is how much? Plus one. Then two hydrogen plus two. This two hydrogen plus two means this sulfur should be how much? Minus two. Why? This both should be equal to zero. Got the point? Okay. Again, now I have given you three things now here. Are a common oxidation number here. What? Flow oxygen I gave mostly minus two, fluorine minus one, hydrogen plus one. Mostly use that, right? But when O and F there, use the fluorine because fluorine is mostly electronegative. Right. I'll give one more. Now we did things with two things. No? But I'll give time to write. Right. Now I'll give another one. H3. Now only I'll give things with three. H3PO4. Now I have to find the phosphorus oxidation number. They're asking you to find the phosphorus oxidation number. Okay. Then I have to divide for how many boxes? 1, 2, 3. I have to divide for 3 boxes like this. Right. I can I can take here. I can take here. Right. Now H3PO4 I'll take like this. Then now 3 boxes. Hydrogen and oxygen, you know the oxidation numbers, no guys? What is the oxidation number of hydrogen? Plus 1. Then 3 hydrogens will be plus 3. 1 oxygen I took as what? Minus 2. Then 4 oxygens minus 8. Then what should be the phosphorus oxidation number? Plus 5. Very good. Plus 5. Why? Because this is plus 3, this is minus 8. Mean to make it 0, this should be plus 5. So phosphorus oxidation number is plus 5. Did you understand clearly? Is it 100% okay? Right? Okay, so these are the ways you have to think. You can write phosphorus is plus 5. 1 hydrogen is plus 3. 1 oxygen is minus 2. Right? Same way you can write here hydrogen is plus 1. Sulfur is minus 2. Right? Here oxygen is plus 2. Fluorine is minus 1. Okay. Okay, I'll give one more. Okay. Okay, no? Any doubt? Ah, very good. You're a very intelligent boy. 1 hydrogen is plus 1. Yes. Okay, excellent, excellent. Superb. Right. Guys, I forgot to tell you. You guys are registered for that exam. This Saturday exam. Huh? No, no, get registered. This Saturday you all ready, right? For unit 1? Okay. All the best. Write it well. Are you coming to write the exam? Saturday. You're coming? No? Come, huh? Right? You come, write, and enjoy and go. Everyone coming, everyone can come to write the exam. Don't miss the exam. Unit 1, study thoroughly. Everyone have the notes for unit 1. Everyone got the complete note. Right? And again, you all study. Okay, again, if you don't have notes, put share with your friends. You have connections, no? You guys. In connections are there, no? Right? Right? Okay. You guys have connections, no? Get the numbers and go. At least you can do something. Right. Then this is H3PO4. Even online students, from online students who are coming to write the exam here. Online students who are writing the exams today. Sorry, today name is Saturday. This Saturday. Okay. You're coming to write? Online students will get the paper on Sunday. You guys get the paper on Sunday, so you can submit. Otherwise, you can come and write. Physical students, you should come and write physically. Okay. Right. Now, tell for this one. H2SO4. Come on, guys. I want to find the oxidation state of sulfur. Then how can I find the oxidation state of sulfur? First, one is plus 1. Both the hydrogens are plus 2. 1 oxygen is minus 2. 8 oxygens minus 8. This is plus 2. This is minus 8. Mean what is this? Plus 6. Very simple, no? So hydrogen is plus 1. Sulfur is plus 6. Oxygen is minus 2. Got the point? Right. Now I hope you can understand this. First of all, you fill this. I will give questions. Right. Now what are the things you have? From ammonia you got. Even ammonia, no need to draw this figure. You know one, although you don't know nitrogen, you know hydrogen is +1. Using that, you can get. Sorry, Tatagala, mark these things. Okay, first mark these three. Later part, I'll show already, you know, from structures how to get kinic, I have taught you, right? Tatagala to decide these things. Now you all can get the things okay. 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 Now, then I will give you to check few things. You can check now whether you can do these things, right? Okay. Then I will put the atom, what you have to find. You have to find that particular atom's oxidation number. Okay. Okay. Done, guys. Okay. Okay. Gal, you have to do this and gal, you have to find. I will give how many questions shall I give? 10? 3. Okay. Fine. I'll give 5. You guys are ready? Online students, did you understand these things clearly? You just put a message whether you understood this. Online students, yes, good, nice. Okay. Now, we'll give you 5 examples. Online students, you all put the answers in the chat box, right? I will give the uh, compound and I will tell which one you have to find, right? Number 1. Number 1 is HNO3. In this, you have to find the nitrogen's oxidation number. Number 2, HClO. In this, you have to find chlorine's oxidation number. Number 3, you have to find for HClO2, you have to find chlorine's oxidation number here. Number 4, you have to find H2SO3. You have to find the sulfur's oxidation number here, right? Number 5, pH3. You have to find phosphorus oxidation number here. Taggala do these guys, 5 things. And the online students, you can put the answers in the chat box. right? Put the answers in the chat box. Done, guys. Okay. Then, okay. Now let's see. Okay, what's the charge on nitrogen here? HNO3. Yes, very good. HNO3, nitrogen will be plus 5. Very good. How nitrogen will be plus 5? This is minus 6. This is plus 1. So nitrogen will be plus 5. Okay, well done. Online students, very good. Now, everyone put your answers in the chat box. HClO, what was chlorine's oxidation number? Plus 1. Very good. This is minus 2. This is plus 1. So chlorine is plus 1. Okay. HClO2 plus 3. HClO2 plus 3. Okay. One oxygen is minus 4. This hydrogen is plus 1. So this is supposed to be plus 3. Very good. H2SO3. H2SO3. One oxygen is minus 2. All are minus 6. Then here plus 2. Minus 6 and plus 2. How much? Puta? Plus 4 here. pH3. What is the phosphorus? This one. This is plus 3. Phosphorus is minus 3. Right? Good. So very simple. So everyone understood this one? Right. Now I told for ions. Now these are compounds. These are not charged ions. Now I told if there are charged ions, that oxidation number is equal to what? Their charge. Oxidation number is equal to their charge. So for an example, we'll say you have PO for 3 minus. PO for 3 minus. Now you have to check the phosphorus oxidation number. What is the phosphorus oxidation number? If you want to check the phosphorus oxidation number, Buddha, you have to do like this. You have to separate this. One oxygen is how much? Minus 2. Then 4 oxygens? Minus 8. Then Buddha, this answer, whatever the answer you are putting here, this one should be equal to how much? Minus 3. I said if there are ions, that ions oxidation number is equal to their charge. The final oxidation number should be minus 3. To get minus 3, what should I put here? Plus 5. Whereas plus 5 and minus 8, I can get minus 3. Got the point? We'll think NO2 minus. NO2 minus, we'll think this ion, NO2 minus. Now, what is oxygen? This one, minus 4. Equal to how much? Minus 1. Then what is the nitrogen's oxidation number? Plus 3 is the nitrogen's oxidation number. You guys clear? 100% understood. Right. So these are enough, no? So you can do the other things, no? Then you can write these things. Or now you can put a subheading oxidation number of ion scalar. Oxidation number of ions. Right. Then first write these two examples. Then you find for these things. Huh? Number 1, NO3 minus. Right. Number 2, H. Here you have to find for nitrogen. HCO3 minus. Here you have to find for carbon. Number 3, MnO4 minus. Here you have to find for Mn, right? Number 4, CrO4 2 minus. You have to find for Cr. Number 5, Cr2O7 2 minus. Here you have to find for Cr. Number 6, HS minus. You have to find for sulfur here. Right. There are 6 questions. Tattagala do this. Right. Now, let's say this. NO3 minus mean. NO3 minus. How you can say this? Oxygen is minus 6 equal to this minus 1. Then I should get here plus 5. Okay. Bicarbonate, HCO3 mean bicarbonate. Here, hydrogen is plus 1. 3 oxygen mean minus 6. Finally, should be equal to minus 1 mean. This should be plus 4. This carbon should be plus 4. MnO4 minus mean. This M is something, N is something. Manganese. Mn is something. Did someone divide Mn separately? No, no. Good. Right? One oxygen is minus 8. Then you equal to minus 1 mean. This manganese should be plus 7. Okay. Then CrO4 2 minus. Oxygen is minus 2, then minus 8 equal to minus 2. Then this should be plus 6. Then can you understand chemistry? There are maths. Right? There is maths in chemistry. Then O7 mean. Mainly remember Buddha in maths, in chemistry, there's lots of mathematical parts. Right? Okay. O7 mean for 1 oxygen minus 2, then 7 oxygens minus 14. Then equal to minus 2 mean this should be plus 12. But how many chromiums are plus 12? 2 chromiums. Then 1 chromium is how much? 1 chromium is plus 6. You got as plus 6. 1 chromium plus 6. Did you write? Good. Okay, excellent. It means you are intelligent. Very good. I'm happy about it. HS minus. S is what? Minus. Sorry. First of all, H no I have to fill. H is how much? Plus 1. Equal to minus 1 mean. Minus 1 mean. This should be plus. Sorry. Minus 2. This should be minus 2. So sulfur is minus 2. Got these points? Right. So those are very important things, guys, and you should understand these things clearly. Right. Okay. Now, very interesting to these things. Right. So then I told once a while, most of the students complicate this lesson. Then, but nothing to complicate in this. No, no, still things yet to come. Right. Today we won't meet anything. Most of the students having a problem in unit 3, mainly when reaction starts to come. Okay. Don't worry, but I will make those things as much simple, maximum simplify. I'll simplify it. Right. We'll see. Okay. Now these things are fine. Now, so far, the basic things are okay. Now, you know how to find the oxidation numbers. Those things are okay, Puta. Right? Now, we'll go for some special states of oxygen. Don't worry, you will learn this one in detail in inorganic chemistry in Unit 6. But I have to introduce these things in Unit 3 as well. Right? It means when you take, there are 3 things of oxygen, Puta. One is normal oxides. Oxygen can form oxides. Oxides mean, for an example, you know magnesium oxide since grade 11. What is the formula of magnesium oxide? MgO. Then can you remember, right, in case if potassium join with that, what is it? Potassium oxide. Potassium and oxygen, it forms potassium oxide. Now, very carefully, you have to say this. I'm going to explain these different types of oxides of oxygen with potassium for your understanding. Okay, then can you remember how to write potassium oxide? Tell how to write potassium oxide? K. Potassium is K, no? K or P? Potassium is K or P? K. Very good. K. KO. K. What? KO2. K2O. Everyone knows it, right? What is your answer, guys? K2O, right? K2O, right? K2O, K2O, right? K2O, right? Again, potassium and oxygen, what will happen? You have to change their valencies and you have to write the valency numbers. Then potassium valency is 1, oxygen valency is 2. So normal, we say this one as, if I write K2O, I can tell this as potassium oxide. This is what? Potassium oxide. Another thing is there, Buddha. Second thing with oxygen, there is a thing called peroxide. We say actually peroxide or peroxide. Have you heard this peroxide word in your life? Right, peroxide word. Then what is peroxide? What peroxide you have heard about? What peroxide? Hydrogen peroxide. Excellent, very good. Then okay, anyone knows what is peroxide? Okay, even online students, very good. You are replying. Excellent, right? You keep it up. Hurry. Then what is? Anyone knows the formula of potassium peroxide? What do you think? K2O2. Well done. Excellent. Because you know H2O2. No? From that will you said K2O2, right? Very good. See, very intelligent, smart boy. Right? Excellent. Huh? It's K2O2. Right? It's K2O2. K2O2. What is that? Potassium. 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 What? Peroxide or peroxide. These things are okay. No? Potassium peroxide. Finally, there is another one. They will make another thing called superoxide. Superoxide, like Superman, superoxide. So these, I'm not telling for jokes. These things are there. They're superoxide. What is superoxide now? Superoxide is, the formula of superoxide is, Puta, right? KO2. This is the formula of superoxide. Okay. Then how you say this? Potassium superoxide. Potassium superoxide. Right? Again? Right. Then, Puta, if I say that, now if they ask you to draw only the oxide anion, now how to decide that? Remember just three examples, these three examples. Just you remember these three examples because you can't remember the oxide anion, peroxide anion, superoxide anion. You can't remember. Definitely, you will definitely miss these things. But it's easy to remember K2O, K2O2, and KO2. K2O means potassium oxide, as you know. Like you can remember the hydrogen peroxide, H2O2 hydrogen peroxide, you know. K2O2 potassium peroxide. And KO2 means potassium superoxide. If you just remember these things, using this, you decide the anion of oxygen. How to decide the anion of oxygen? Now this is O. What is O? Why we have written 2 here, Puta? Because oxygen's valence is 2. Then oxide mean it is, right? Oxide mean it is O2 minus is oxide. Okay, because O2 minus only oxides. That's why O and they have put the valency 2. Okay. Next, peroxide. If you think like that, what would be peroxide? What is the valency I have put for this one? 2. Is the potassium valency is 2? Potassium valency is 1. Then this 2 belongs to whom actually? This 2 belongs to whom? This O2. Either peroxide mean actually it's O2. This 2 because of whatever the charge on this, whatever the charge on this, that because of that only this 2 is there. O2 what? 2 minus. O2 2 minus mean it's a peroxide. Can understand that? Right. Then what is the valency of this oxygen now? You know potassium's valency is how much? 1. Then what is this oxygen's valency? That also 1, right? This oxygen's valency also 1. Why K1? Oxygen's valency also 1, right? Then oxygen valency is 1 mean, Puta. This 2 belongs to whom actually then? That O2. Either a superoxide mean it's O2 minus. Superoxide mean what is it? It's O2 minus. But you will never remember the O2 minus oxide, O2 2 minus peroxide, O2 minus means superoxide killer. You won't remember. But if you remember these examples, from this you can get these anions. Got the point? How to get the anions? Right? All right. And remember peroxide and superoxide, it comes as O2O2. Peroxide O2 2 minus, superoxide O2 minus. Just remember these things. Got the things, guys, clearly. Right. Then you just write. Okay, then what are the oxidation number of these things? Oxidation number. Oxidation number of oxygen here. oxidation number of oxygen. Oxidation number of oxygen. Oxygen. It's very simple. We can decide like this. I'll put it here. Oxidation number of oxygen kilo. I'll take it here. Oxidation number of oxygen. It means if I write potassium superoxide, potassium oxide. But I told you to remember. Normally I said to take the oxygen as -2. But here now we have to find oxygen. Therefore, don't take oxygen as -2 here. Think about potassium. Potassium is a group which belong to group 1. No people. Oxidation number is +1. Group 1 people oxidation number is +1. Group 2 people oxidation number is +2. If you have any group 1 or 2, you can decide like this. Then potassium, 1 potassium is +2. 2 potassiums. Sorry, 1 potassium is +1. 2 potassiums +2. Then what is this oxygen valence here in K2O? -2. Then in oxides, oxygen valence is -2. Right? In peroxides, peroxide means K2O2. This is peroxide. In peroxide, Puta, 1 potassium is +1, then 2 potassiums are +2. This is +2 mean this one should be -2, right? This is -2 mean 1 oxygen is how much? 1 oxygen is -1. Then understand in peroxides, oxygen valence is what? Oxygen oxidation number is what? -1. Always 1 potassium is +1. Because always group 1 elements are +1. Okay, group 1 mean lithium, sodium, potassium, rubidium, cesium. All these people, always oxidation number is +1. Then if I take KO2, this is potassium superoxide. When I take potassium superoxide, what is the potassium's oxidation number? +1. Then this both the oxygens are -1, right? Then 1 oxygen is how much? 1 oxygen is -0.5. Then do we have 0.5 oxidation numbers? Yes. Yeah. Can you see oxygens in superoxide? Oxygen is -0.5. So these are very important things. So these are some special case of oxygen. Okay, so you have to remember. Normally, if you have this potassium and all, like sodium, potassium, always remember sodium, potassium, rubidium system, always they are +1. Okay, always they are +1. Right? Those things you all just put a note. Okay, sodium, potassium, these people are always +1. Okay, again you can put here. Okay, group 1 oxidation number is what? +1. Group 2 oxidation number that is +2. Group 2 all the elements oxidation number is +2. Group 1 all the oxidation, but group 3 we can't tell like that. For group 3 we can't tell all are +3, him we can't tell. Only group 1 and 2 we can tell all the oxidation number are +1. Group 2 all the oxidation numbers are +2. Beautifully write this under the heading. Okay, oxygen's special killer. Oxygen special, right? O special. Okay, right. Now Tagala write these things. Beautiful, write each and everything very neatly. Okay, under this put the oxidation numbers also put under here. Oxidation number kila ON oxidation number. You just put this is oxides -2, peroxide -1, superoxide -0.5. Okay. Oxygen is always special, right? Correct. Okay. These things are fine. Now, almost everything related to oxidation number is fine, right? So you have to, most of the places it comes as -2, right? But special case also there. But remember then, if you get a group 1 element and oxygen, normally this case comes only with, don't worry, there is no, this one, they won't make superoxides and peroxide with everyone. Okay, normally oxygen will make superoxides or oxides only with group 1 and 2 elements only. Therefore, don't need to worry in any other places. What you have to remember? It can make superoxides and oxides only with group 1 and 2 elements. It means S block elements only. You will never find a oxide or superoxide with any other groups. Therefore, in any other group, if you get oxygen, always the oxygen is what? -2, except with fluorine. Got these points? Onang, you write those points as well, right? Oxygen can make peroxide and superoxides, only with S block elements. Only with S block elements. Remember, this is a very important point. I'm not going to tell who are the people they can make superoxide, who are the people they are going to make peroxide, because I don't want to elaborate this. But in unit 6, you will learn who can make superoxides, everything we will learn in detail. At the moment, just you have to remember now, only S block people can make superoxides and peroxides. Okay. Then you can write all the other places, oxygen's oxidation number is -2, except OF2, except OF2. Only OF2 is having oxygen +2 oxidation number. All the other places wherever you see oxygen, it is always -2. Very simple, no? Oxygen, you got to confuse, no? I don't know, this bugger is dancing with different oxidation numbers, then it's a very big problem, Kayla. Now, no problems. Now I gave a clear idea how to get these things, right? Okay. Then these things are fine so far. Okay. Now, everything related to this oxidation number is fine. Now, we'll do oxidation numbers related to structures. Already you know this, but I think this is a part of this lesson. Then I have to teach you that part also. Now, we'll think about the S2O3 2-. We'll think like this. Certain things we have to go through structures. Now, if I give S2O3 2-, Puta, if I ask you to find the sulfur's oxidation number, you can find. Find sulfur's oxidation number. First write the heading. Oxidation numbers related to structures. Oxidation numbers related to Lewis structures. Oxidation numbers related to Lewis structures. Decimal numbers. Huh? Oxidation number related to Lewis structures. Oxidation number related to Lewis structures. Oxidation number related to Lewis structures. All right. Now we have to discuss the oxidation number related to Lewis structures. Good. Now, if I tell oxidation number related to Lewis structure, Buddha, now did you find this sulfur's oxidation number? You got as +2. Right. +2, you will get the answer. But actually, sulfur is not +2 here. Okay. Again, actually, this sulfur is not +2. I thought earlier ones, then that also will be wrong. No problem. But here there is a small case, right? Again, only you have to remember this, especially about this ion. This anion is special anion. This anion's name is, can someone remember this anion's name? Are there anyone? If you can remember, actually, we have to give a reward for you, actually. Anyone knows this ion's name? Anion's name? Any online student? Yeah, it's related to sulfur. Already, can you remember? We did some anions when you are doing unit 1. Or, we did anions. Can you remember? Right. Okay. Then, yeah, okay. I'll tell the name, right? You find so hardly you're doing something. Find it, find it. It's fine. It's fine. Find. At least you're trying something. We appreciate it. Could you get it? Couldn't you get it? Isn't it there? Not there? Are you sure? Uh, certain things we didn't write. We haven't written that. Hurry. This one known as Puta, thiosulfate. This one known as what? Thai name. Thiosulfate. Thiosulfate kila we tell this. And we call another name for this thionate. Thionate. Thionate kila we tell this. S2O3 2 minus. Thionate or thiosulfate. Remember, Shukry, you have to remember this product specially. Normally, other places you don't have this problem from the things, whatever you are learning, from the anions, whatever you are learning. Other things are fine. You can use the other method. But S2O3 2 minus, if you want to find the oxidation number of sulfur Puta, you have to draw the structure of S2O3 2 minus. How can we draw the S2O3 2 minus structure? Very simple. First, draw 2 sulfurs like this. 2 sulfurs and 3 oxygens will connect to this sulfur. That's it. Just remember like this. S2O3, don't forget it. How to write S2O3? Connect the 2 sulfurs. Then for this sulfur, 3 oxygens will connect. Now I have told you, no, Buddha, how things will connect for this. Now this sulfur is the central atom. This sulfur is the central atom. Then I have told you, now this is a oxyanion. And I told in oxyanions, this minus charges will fall on which atom? Oxygen atom. Then I have to put 2 minus on 2 oxygens. Then the other rest of the atoms should connect to this sulfur with their what number? Valency number. They should make the bonds equal to their valency number. What is oxygen's valency normally? 2. Oxygen valency is 2. Then oxygen will connect with sulfur with 2. Sulfur also belong to 16th group. No? Below oxygen only sulfur is there. Oxygen is up, sulfur is down. Same group. So sulfur's oxidation number also, common oxidation number is, common valency is what? 2. Then this sulfur also will connect this with 2. Then now around the sulfur 1, 2, 3, 4, 5, 6, 6 bonds only, maximum number of bonds. Okay. Everything fine. So this is the structure of thiosulfate ion. Now I have to find the sulfur's oxidation number mean Buddha. Now last class also I have taught you, but anyhow, today also I will repeat it again. Each bond we put plus minus. For each bond we put plus and minus. And I told you, whatever the most electronegative element will get the minus, least electronegative element will get the plus. Now in this sulfur and oxygen, who's most electronegative? Oxygen. Then this oxygen will get a minus. This sulfur will get a, yes, very good, plus 1. This oxygen will get a minus and this sulfur will get a plus 1. This oxygen 1 bond, this bond will get minus 1, this will get a plus 1. This will get a minus 1, this get a plus 1. Then this sulfur and this sulfur, are there an electronegative difference? No. Then no one will pull the electron towards that side. They are equally distributed. Therefore, this is 0, this is 0, this is 0, this is 0. Then if I want to calculate this sulfur's oxidation number, I have to see this. I have to see this. Okay. I have to see this. I have to see this part. If I see this one, you get the sulfur's oxidation number. What is the sulfur's oxidation number? +1, +2, +3, +4. This sulfur is +4. This sulfur's oxidation number is +4. What is this sulfur's oxidation number, Puta? This sulfur's oxidation number is 0. This oxidation number ON is 0. This sulfur's oxidation number is +4. Got the point? All the oxygen's oxidation number is how much? This oxygen's oxidation number? This oxygen's oxidation number? There is a minus charge with this -1 altogether. -2. This one also same thing. These two same thing. This oxygen also what? -1 and -1 mean oxidation number of this oxygen also how much? -2. Finally, what are we getting? These both average we are getting as +2 actually. But actually one sulfur is in +4 sulfur, other sulfur is 0 sulfur. Okay, there is a small you have to remember only this as a from the structure. That's it. So only remember about the thiosulfate anion. Only in the thiosulfate anion, one sulfur is in what from whatever things in your syllabus. One sulfur is in +4, another sulfur is in 0. Got the point, guys? Right. Beautifully mark these things. Start. I think the period people, the central atom only, they can make equal number of bonds equal to central atom. Central atom is also they can make up to equity. But the surrounding atom, they will count equal to them. Okay. Right, guys. Now, these things are fine. Then S2O32 minus is fine. Okay. Now we have to go for a small calculation part after this, right? I have to go for empirical formula. There is a thing. And molecular formula. You know those things? How you know those things? Ah, you are going to school no? Ah, nice. You guys have started those things. You guys, you already told me like you're directly going to start from unit 3 here. Ah, right. Okay. Then, okay. So did they start something? Right. Okay. Fine. Then these things are fine. So today we have to speak about empirical formula and okay, molecular formula. Those two things. Those are small things. Huh? Everything small things. Whatever we are going to do today, everything small things. Main things will come in next class. Right. This is a very important session. We'll take a small 10 minutes break. After that, we'll continue. Only 10 minutes. Huh? In 10 minutes, if you want to drink something, drink. If you want to eat something, eat. Or if you want to sleep, you sleep. The 10 minutes I will give. Then we'll come back in 10 minutes. Okay, now see this part. Okay, now see this. Now, all the online students, for the structure, don't worry about the structure. This is the structure what you have drawn in the Lewis structure, right? Now, don't think how to create the structure is not a part of this lesson. Here, this lesson's part is how you have to identify these things, right? Lewis structure is a separate part. Don't worry about the Lewis structure here. Just you see how to understand how to get the oxidation numbers, right? Your problem was for drawing the structure. That comes under Lewis structure, right? Now, if I start to explain how to draw Lewis structures, it will take a large amount of time. Okay, so Chuttak, you can see those recordings and you can complete those areas, right? Now, Buddha, come, we'll go for the thing is empirical formula and molecular formula. First of all, you should know what is this empirical formula. Empirical formula is important. Careful listen. Empirical formula. Empirical formula mean Puta, the simplest formula of a compound. Empirical formula, right? Empirical formula, right? Right. Empirical formula. You guys in a mood to listen these things, but now, right? Empirical formula. Okay. You can eat your snacks and you can listen this, no problem. This even you can share it too, right? Hare. So empirical formula and empirical formula you can write the simplest formula, the simplest formula, the simplest formula of a compound, the simplest formula of a compound, the simplest formula of a compound, the simplest formula of a compound. Now here this is now calculation part. Now they will tell you, okay, they will tell you in a compound, right? Write this, Puta. Okay. In a compound, carbon is equal to 61.2%. Hydrogen is equal to 8%, right? Then oxygen is equal to this 8% mean oxygen should be how much? 61 and 8, 69. 69.2 mean 30. 30.8. Oxygen 30.8% kilo we get. Okay, right. Now, and then find the empirical formula of the compound. Find the empirical formula of the compound. Find the empirical formula of the compound. Okay. Now on the empirical formula, Buddha, now they will give within brackets, they will give carbon is equal to 12, hydrogen is equal to 1, oxygen is equal to 16. They'll give like this, right? They'll give what is this empirical formula. Okay, right. Now, Buddha, what you have to do, first of all, you write CHO. Now this compound is made out of CHO. Carbon is 61.2. Very easy, yeah? 61.2. Hydrogen is 1. Hydrogen is 8. Oxygen is 30.8. What you do, you divide all these numbers with their RAM. What is RAM? Their relative atomic mass. Okay? You just find these with their relative atomic mass. When you find these things with their relative atomic mass, we'll think carbon is 12 divided by 12. Hydrogen is 1. Oxygen is 16. We have to divide this. Now 61.2 divided by 12. Now you should know division. Now if you can't divide the thing, you will face a problem here. Don't use calculator. Don't use calculator. You might we don't know division, but our cal knows division. Okay? Divide by 12. There are 5. 60. Here? 1. Then bring the 2 here, then 12. Then 5. 5.1 kilo you get. You get here 5.1. 8 divided by 1 is how much? 8. 30.8 divided by 16? 30.8 divided by 16. 16 how much? 1. 16, then 14. Bring the 8 down, 148 and put a point. I guess nearly 9. 9 are there, no? 9 into 6, 54. 9 to 1, 9. And 144. Okay, I just guessed that. Then we get 1.9. Then what you have to do now, after getting these answers, from all these answers, you have to divide by the smallest number. You have to divide all these things by the smallest number again. But what are you doing? Don't write. Now you have to divide everything by the smallest number. 1.9 divided by the smallest number mean, what is the smallest number here, Buddha? The smallest number is 1.9, then divide by 1.9. This also divide by 1.9. This also divide by 1.9. Okay. Then 5.1 divided by 1.9. How much you guess? 5.1 divided by 1.9. Again, normally when you are going to divide by 1.9, you have to make it as a whole number. It becomes 51 divided by 19. You all can understand? Then how many 19s are there in 51? Like 20 is there if you think 2, 38. 11 minus 8 how much? 3. Then here 13. Then 130 point. Here how many are there? 6 again. 6 into 9. 6 into 9 how much? 6 into 9 how much? 54. 6 into 6. 114. I think we can go up to 7, right? Put on the 7 and the van. When I can say, you say again. Pull again or I will. Can't, right? 16 remained. So 2.6 again only we get. So it will 2.6 here. 2.6. Then 8 divided by 1.9. Nearly. We'll put 4 kilo. 8 divided by 1.9, something like 4.1 kilo will take. It will come as 80 divided by 19. Then we'll put here if I put 4. 4 into 9, 32. 72. No? Remained 8. No? Then 4.4 again we get. No? Again, no? 4 into 9. 9 for 36, right? 9 for 36, I'm sorry. Then 40. 40 means something 4.2. 4.2 kilo we get. Here 1. Now we get these numbers. No? Now C 2.6. Hydrogen 4.2. Oxygen 1. Remember that when you get these numbers, always you have to get the nearest number. Okay. Again, in normally empirical formula, these compounds can have only what? Whole numbers. Therefore, they can have whole numbers. Therefore, what you have to do, guys, right? You have to take the nearest numbers for this. Nearest numbers mean carbon 2.6 mean nearly how much? Nearly 3 kilo we have to take. 2.6 if it nearest number kilo, what we have to take? 3. 4.2 mean nearest is 4. This one 1. Then what is the final empirical formula of this? C3H4O tamai formula. This is the empirical formula. Did you understand this? Is it 100% clear? Right, C3H4O. But remember, Puta, in case, careful remember, and a question will do. At the moment, question I don't know, we can get that. Remember, it's a special point you have to remember. We'll say anything comes as 0.5 for an example, you think you got 1.5 or something. You got 1.5 or something. If you get 1.5, we don't take the closest number for this as 2. Here we don't do. Like 0.5 exactly if you get. What we do, guys, we have to multiply it by 2. We have to multiply this by 2. If we multiply this by 2, how much we get? 3.0 kilo we get. And we have to get whole numbers here. We have to get whole numbers by multiplying. Right? That's the correct way. Right. Then beautifully write these things. This point you should remember. If you get 1.5, if you get a value with 0.5, 1.5, 2.5, anything, remember to get the empirical formula, you have to multiply by 2 key and a point. Just put somewhere in corner. Right? Okay. Then write this entire thing. Beautiful. No need to show the divisions, right? You can just do this part. Finally, the empirical formula is C3H4O. Online, you can put the steps. Step 1, divide by RAM. Step 2, divide by the smallest number. These are the 2 steps you have to do. Okay, there are only 2 steps. Divide by the RAM and divide by the smallest number. Those things you all can mark it. You're done? How? Write these extra points. Wrote? Even you wrote this, divide by RAM, divide by the smallest number. Step, 2 steps. When you go home after that, you will get confused on why we put 1.9. Not after 3 months. Therefore, you write these things. Yeah, write that. You're getting something like 1.5 or 2.5, you have to multiply by 2 to get whole number. Okay. Are these things okay, guys? Right. Now, second thing, with the molecular formula. Then you write next one, molecular formula. Molecular formula. Now, empirical formula part is okay. Next one, right? Molecular formula. Molecular formula. Under molecular formula, you can write. Under molecular formula, you can write like this. The real formula of the compound. 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 Okay. The real formula of the compound. Okay. Right. Right. The molecular weight of the above, the molecular weight of the above compound, the molecular weight of the above compound, the molecular weight of the above compound is 224 grams per mole. 224 grams per mole. 224 grams per mole. Find the molecular formula of the compound. Find the molecular formula of the compound. Find the molecular formula of the compound. Right. Find the molecular formula of the compound. Okay. Right. Now, you want to find the molecular formula of this compound. Then, what should you do? Again, which compound? For the same question, it's a continuation of the same question. Now, we have found the empirical formula. What do you mean by empirical formula? The simplest formula. The empirical formula is the simplest formula. Then we'll see, okay, what is this empirical formula's weight? We'll see that molecular weight of C3H4O. We'll see C3H4O's capital M we'll see now. With the capital M of C3H4O, Puta, you get here, right? You get for this. One carbon is 12, then 3 are there. One hydrogen is 1, there are 4 hydrogens. One oxygen is 16, there is only 1. Okay. Then if you add all these things, you get here 36 and 4, 40, 40 and 16. You get 56 grams per mole. This is weight of one C3H4O. Then how many C3H4Os will be in the molecule? That's only you have to see. So what you have to do, okay, to find the real molecular formula, you have to find what is the empirical formula molecular weight. Is empirical formulas molecular weight multiplied by N is equal to, okay, is equal to, okay, molecular formulas molecular weight. Okay. If you put this, you can find N. N means how many things are like this are there. Okay, this is no need to write a formula for this. You can think and do that. Okay, 56 times how much is, okay, this 224 kilo only you have to check. Then you have to find N. Then N is how much? 224 divided by 56. Then how many 56 will be there? N equals 4. Then there will be 456 will be in this. So N is 4 mean there are 4 times C3H4OR in this, in the real formula, right? Then you can write the molecular formula. Molecular formula the molecular formula will be equal to C3H4O multiplied by 4. If you multiply this by 4, and then you get the answer. Then that is the real molecular formula. C12, H8, H16, O4 is the molecular formula for this. You have to find how many, this is the basic one, like this basic one, how many things are connected, you have to search here. Right? Is it clear, guys, how to get the molecular formula? Right? You won't confuse this now? Right. Beautifully write this. Online students, are you okay, guys? Type yes, no. Are you okay with this? Molecular formula? Yes, good. Ah. Are you done? Okay, guys. Done? Okay. Now we'll see what is the empirical formula of this compound. Okay, you all only have to find this. Okay, we'll go for the second one. Okay, now you know what is the molecular formula and what is the empirical formula. So those two things only we got here. Right. Now we'll think like this, another one. Okay. There are so many type of questions are here. This is the most basic type is this. Out of that we will do different types of questions. So careful listen. You think this carbon here, you think you got carbon, 48% of carbon here. Okay. And hydrogen will be something like, I think 12%. Hydrogen will be 12%. Oxygen will be 40%. Then first question, do the first question, find the empirical formula. Right, Tagala do this, find the empirical formula. Everyone Tagala find this. Your online students find this and put the answers in the chat box. What is the empirical formula for this? Make it first. Right. Now this, you got the empirical formula, guys. You have to make your division fast. Huh? Okay, online students, well done. You have got the answers. Superb. Right. Now, you have to get the empirical formula. For carbon, you have 48. Hydrogen, 12. Oxygen, 40. Then you have to divide this by their relative atomic mass from the RAM. If you divide this, you get 4 here, you get 12 here. 40 divided by 16, but if you can simplify, simplify. Okay, 40 and 16 are again simplify by 4. Then 10 divided by 4, then 2.5. Right? Then divide by 2.5. Divide by 2.5, divide by 2.5. So 4 divided by 2.5 mean, what is it actually? 40 divided by 25. You can make this as a whole number by sending the point here, then 25, then 4 become 40. 40 and 25, you can simplify. You can simplify this. 40 and 25, you can simplify by 5. Then you get 8 here. You get 5 here. 8 divided by 5, how much? 1.6. You people are more suffering. You can get this. 1.6. Other one, 12 divided by 2.5. 12 divided by 2.5 mean 120 divided by 25. This also you can simplify by 5. So if you simplify by 5, you get 5 here. If you simplify by 5, you get 24. 24 divided by 5 mean, then you get 4.8. Right? Easily you can simplify this. So 4.8, this one. Now you have to get the closest number. 1.6 mean nearly 2. 4.8 mean nearly 5. This one. Then what is the answer? C2, H5, O is the answer. You got this, right? You got this, but you took time. Right? Okay. Next one, write like this. The molecule, right? Second one, B part. Again, the first one, the empirical formula. The second one, right? The above empirical formulas, molecular weight is. The above empirical formulas, molar mass is. The above empirical formulas, molar mass is 225 grams per mole. 225 grams per mole. 225 grams per mole. Find the molecular formula. Find the molecular formula of the above compound. 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 Right. Now, Tagala, find this. Find the molecular formula of the above compound. Quickly find the molecular formula of the above compound. Done? Finish? Finish? MashaAllah, very good. What's up? Super. How did you finish so quickly? Sata Satagala you did. Well done. Right. Then, Buddha, you can, first of all, you can find the weight of C2H5O. C2H5O, you can see the molar mass, capital M of this. So, carbon is 12 into 2, hydrogen 1 into 5, plus oxygen is 16. If you add all these things, you get 45 grams per mole KL. So, you can write this 45 times N is equal to this 225. Then N is equal to 225 divided by 45. You get N is equal to, if you divide this, you get N is equal to 5. If N is 5, what you can do, you can C2H5O is here. This entire thing multiply by 5. If you multiply by 5, Putta, you get the molecular formula as C10H25O5. Got this? Okay. So here everything about your simplification speed, right? Slowly they will give a small question based on this, right? Don't think this is the entire main thing. There is some this is a main type. This is a main type of this empirical formula. Then are there other types to find uh, any formulas? This molecular formula. Do you have any other way to find? Any other way? I mean, this is the main way. After that, there are from using reactions also we can find molecular formulas of compounds. They have asked in the past papers as well. Okay, certain past papers also they have asked this, right? Then we'll go for a past paper question. How they have asked this. Okay, I'll just take from a past paper question. How they have asked this. Okay. All right. Hmm. All right. They have given a question in past paper. This is another type. Okay. Right. Finding. Write a subheading. Finding. Finding molecular formulas. Finding molecular formulas using reaction. Finding molecular formulas using reaction. Finding molecular formulas using reaction. So this is a past paper question. I can't exactly remember the year. Like 2009, 2010, they have asked some question like this. Uh, they have given these information. Should Tuck write these informations? Tuggal write these informations. Write like this. Uh, the relative atomic mass of M, the relative atomic mass of M, sorry, the relative atomic mass of M is equal to 62. 62 kilo is relative atomic mass, we don't have a unit. The relative atomic mass of M is 62. Okay. Then during combustion, what is combustion? Burning. During combustion, M releases 88 milligram of CO2, 88 milligram of CO2, 88 milligram of CO2, and 54 milligram of water. And 54 milligram of water. Find the value of XYZ. Find the value of XYZ. Find the value of XYZ. XYZ. Find the value of XYZ of the molecular formula CXHYOZ. CXHYOZ. Then they have given carbon equals 12, hydrogen equals 1, oxygen equals 16. They have given these things. Right. Now, this is a different type question, right? Now, the same type, this is a different type. They have given questions like this as well. Milligram. 88 milligram of CO2 and how many milligram of water? 54 milligram of water. Right. Okay. Now, we'll see how to do this type of question. How to find the molecular formula of this one using these reactions. All right. Now, first of all, we'll write this reaction. Now, I said when you burn M, right? When you burn M, Buddha, can you guys come this side? Can you come to this? It will be easy for me. No, don't take anything. Just take your books and pens. Just keep your items there. Take your books and pens to this. Tagalog. Why are you going away? Why are you going away from him? Right. Okay. So when you burn M, you can M plus O2 no Buddha. M plus O2, it should release CO2 and water. It should release CO2 and water. And how many milligrams of they have said how many? I told you how many milligrams of M you are burning. Did I tell? Did I tell how much M is burnt? 62 milligram. Again, in that question, then write it below. Capital M's mass is 62 milligram. Capital M mass is 62 milligram. No, I gave the mole relative atomic mass. Capital M's mass is also 62 milligram. Capital M is 62 milligram. Put that, guys. Capital M is equal to 62 milligram. Now I said capital M is 62 milligram. CO2 is 88 milligram. And H2O is 54 milligram. I gave these things. Now with these informations, now I have to find this molecular formula. Now for the CO2, I know it is 88 milligram. Now this is a past paper question. No? 88 milligram. This is 88 milligram. H2O, I know 62, 62 54 milligram. 54 milligram. And I know capital M moles how much? 62 milligram. First of all, we'll see the moles of this. But how many moles are here? How many moles? Without, we have to connect these with number of moles. How to find number of moles? I have to find number of moles here. How to find the number of moles, guys? I have divide 62. 62 milligram. Now I need to find the number of moles. What is the formula? N equals simple M over capital M. I have to apply this formula. Simple N equals simple M over capital M. I have to use this formula. If I use this formula, what is simple M? Mass. Capital M in molar mass. So normally mass I have to include in what? Grams or milligrams? Capital M I have to put in grams. Sorry, simple M I have to put in grams. Capital M I have to put in grams per mole. Right? Then 62 milligram. If I want to convert to gram, what should I do? Divide by 1000. Milligram, if I want to convert to grams, what should you do? Milligram, if you want to convert to gram, what should you do, guys? Divide by 1000, right? Divide by 1000. Okay, at a small to big, you divide. Okay, that pattern, remember, right? Puta me bola milligram to gram convert karana, right? Milligram to gram mean what should you do? Divide by 1000. I said a pattern in chemical calculation nights. How to write divide by 1000? Using multiplication, how we write it? Multiply by 62 multiply by 10 to the power minus 3. You can divide by 1000. I can indicate multiply by 10 to the power minus 3. That what does it mean? Divide by 1000. If you want to divide by 100, multiply by 10 to the power minus 2. Are these things clear? Right. Now, capital M's molar mass also I know. What is the molar mass of capital M? 62. Then I will get here 1 into 10 to the power minus 3 moles scale I will get here. Then I have to divide this one also, CO2 also, to find the number of moles. What is the molar mass of CO2? You can see in a corner. What is the molar mass of MCO2? Capital M CO2 is 44. Count and see, you get 44 grams per mole. Right. Because carbon is 12. 2 oxygens are 32. 32 and 12, 44. So 88 divided by 44 will be how much? 88 was a milligram. To convert to gram, I have divide by 1000. How to write divide by 1000? Multiply by 10 to the power minus 3. You are not getting confusions, no? Right. Then what you get? 88 divided by 44 mean answer will be 2 into 10 to the power minus 3. But moles. 2 into 10 to the power minus 3 moles. If I divide this, 54 mean 54 into 10 to the power minus 3. Water molecule is 18. If you divide by 18, we get 3 into 10 to the power minus 3 mole. Right? We get 3 into. I get 3 into 10 to the power minus 3 mole. Okay. So this is 1 in 10 to the power minus 3 mole. This is 2 in 10 to the power minus 3 mole. This is 3 into 10 to the power minus 3 mole. So if you take for 1 mole of capital M, if you take 1 mole of capital M, okay, again you can understand, you have to understand with the ratio. Okay. If you take 1 mole of capital M, how many CO2 moles you get? These 1 into 10 to the minus 1, this 2 into the what in 2 into 10 to the minus 3. Then from 1 mole of capital M, how many moles of CO2 you will get? 2 moles of CO2 you should get. And how many moles of water you should get? you should get 3 moles of water. From 1 mole of this one, you should get CO2 2 moles and water 3 moles. Can understand that? Okay. Again, when you're doing this question, you have to understand from 1 mole of M, okay, from 1 mole of M, from 1 mole of M, you get CO2 2 moles, you get water 3 moles. Then how many moles of carbon are in this, Putha? Carbon mole. Carbon mole. How many carbon moles will be there? In CO2, how many carbon moles are there? There are CO2 2 moles. In CO2 2 moles, how many carbon moles are there? Confused? In CO2 there are 2 moles. In 2 moles of CO2, how many carbon moles are there? Answer. 2 moles. In CO2 2 mole, how many CO2, in how many carbon moles are there? 2 moles. You have to understand. Huh? Wait, I'll show you. This CO2 no Buddha. CO2, if you break it, carbon dioxide, if you break into atoms, you have how many carbon atoms? 1 carbon atom. How many oxygen atoms? 2 oxygen atoms. Can you understand? Then, if I take this one as how many moles? 2 moles. If I take CO2 as 2 moles, Buddha, how many carbon mole will be here? See the number. This is 1, this is 1, this is 2. If there is no number, mean 1. 1 is to 1 is to 2. Carbon mole also will be how much? 2 mole. How many oxygen moles are inside the carbon dioxide? 2 mean 4 moles of oxygens are inside this. Can understand that? Again, you have to see, again, 2 moles of carbon and 4 moles of oxygen will join together and will form 2 moles of CO2. Can understand this? So this is the meaning. Huh? So here, if you write carbon mole, how many carbon moles are here? 2 carbon moles are here. Okay. How many oxygen moles are here? How many oxygen moles are here? How many oxygen moles are here? Oxygen name, I'm sorry, oxygen moles I don't want at the moment. We'll think the hydrogen moles here. Using this, I can think the hydrogen moles. Okay, what is the hydrogen moles here? This is the amount of hydrogen moles. Hydrogen moles will be, yes, come on, speak. Come on, guys, speak, Tagar. Tell how much? Now, 3 moles of water is there, then how many moles of hydrogen? 6 moles of hydrogen will be there. Why? H2O will break into, H2O can break into, this H2O will break into 2H and 1 oxygen. So if I have 3 moles of water, Putha, 3 mole means this 1, these 2, this 1. Then 3 mole of water means from 3 mole of water, I get 1 is to 2. It means 2 times of hydrogen I will get. Then I get 6 moles of hydrogen here. Okay, I get 6 moles of hydrogen here. Then how many oxygen atoms? Oxygen atom will be 1 mole. Right? Then how many hydrogen moles will be there? 6 hydrogen moles. It means, Buddha, can you understand this molecular formula is CXHYOZ. This molecular formula is CXHYOZ. This CXHYOZ. Can you understand? Again, this capital M mean whatever this capital M, if I burn, this is only CXHYOZ. Can you understand, Buddha, whatever the carbon dioxide forms, those all the carbon should come from where? From this compound. All the hydrogen, whatever comes in water, everything should come from this molecule. But the oxygen will come from CO2 also oxygen is there. This water also oxygen is there. In the reaction also oxygen is there. It is oxygen we can't find using this. But I can, so far now we can remember, we can see this formula is C2 because carbon 2, hydrogen will be 6, C2H6, but O I don't know yet. But I know the molar mass of this compound, no, Buddha. I know the molar mass of the compound. Then I can find and will write O is Z KL. Now how I don't know how many Z's are here. Right? I know only I have found only the carbon and hydrogen yet. But I don't know how many oxygens are in this. So for this purpose, I'm going to find the C2H6 molar mass. Molar mass. Molar mass. Molar mass scale I can find like this. Okay. C2H6O is it. molar mass is equal to C2H6OZ. No? There C2 is how much? 12 into 2. No? One hydrogen is how much? One hydrogen is 1. Then there are 6 hydrogens like this. One oxygen is how much? 16. Then how many oxygens are like there? Z, no? 16 into Z. This is the word Z, not 2. This is Z. Don't confuse 2 and Z. No, no, no. Where oxygen 3 mole? Yeah, water oxygen 3 mole. This water oxygen is 3 mole. Right? Only that one. You asked me to put 3 here. No, no. You just corrected that. Ado, when I'm explaining this, why you are watching that? Right? Ado, focus here. So, Puta, can you understand how I got this? No, I had got the value, get the value only for Z. No? So, molar mass, I know that they have given 62 kilo, they have given the molar mass 62. Then 12 into 2, how much? 24. 24 and 6, 30. 30 plus 16. What is this? Z. 16Z. Put properly like the 2 and Z properly. Some people 2 and Z both are same. Send the 30 to this side. Then 62 minus 30 is equal to 16 Z. 62 minus 30 is how much? 32. Send the 16 to this side, divide by 16 equal to Z. Then 30 divided by 16 is how much? 2 is equal to Z. Put the 2 is Z. 2 is equal to Z. So 2 is equal to Z means finally what is the formula? So finally I can write. This is a very good question which is given in past paper. Okay, the molecular formula is what is the molecular formula? C6 never C2 H6O2. This is the molecular formula. Here no, you can't find the empirical formula from this. You can find only the molecular formula from these type of reactions. Huh? No, sorry, I'm sorry, not that. You can find the empirical formula also. Yeah, this is MCQ question. This is MCQ question, right? So this is MCQ question in that particular year, right? So you have to find the answer for that. Molecular formula is this. If they ask the empirical formula, you should be able to tell the empirical formula for this as well. Empirical formula, so you can tell from the molecular formula. What might be the empirical formula? You use your super mighty brain, and if you can tell the empirical formula, CH3O. Well done, excellent, super. Everyone got that answer? Why? What you have to do? You have to write this in the simplest form. If you write in the simplest form, you have to simplify this. You can C2H6O2 mean everything you can simplify by 2. Then the empirical formula is how much? CH3O. You have to write in the simplest form. Okay. You can be seeing a molecular formula, you can predict the empirical formula as well. This is a very good question. Is it difficult? No. Can understand how it works, right? So you have to understand using the mole ratios. Again, you have to see how many carbon moles are there, how many hydrogen moles are there. Okay, these are very common. It means, remember, using CO2, you can find the carbon moles. Using hydrogen, you can find the hydrogen moles. Directly, you can put for this. And finally, you can see the molecular weight and you can decide how many oxygens are there. Right? Got the point, people? 100% clear? Right, nice. Then, what should you do? You have to write all these things beautifully. So write one by one. Online students, did you understand this part? Guys, is it clear? Online people? Right. Nice. Well done. Okay, excellent. So how come 44? So I didn't understand only that 44 and 10 part. What is 44? This 44 is put the CO2's molar mass. 44 is CO2's molar mass. Carbon is 12. 2 oxygens are 32. 12 and 32, 44. That's how I got 44 here. and 10 part. What is 10 part? 18. 18. This 18 is molar mass of water. 18 is one oxygen is 16, two hydrogens are 2. Then 18 molar mass of oxygen. And I found the moles by dividing by their molar mass. This 62 is this capital M's molar mass. Okay, understood. Right, good. If you have doubts, you can ask online people. Right. There's we respond to online as well. Okay, good. Putha, still this lesson is boring. It became powerful. Right. Anyhow. Then, okay. Okay. Then, so these are things you got here. Right. Now, Buddha, remember this Saturday, you have the paper at 1 o'clock. 1 to 4 p.m. we have scheduled 3 hours paper. In that, you will get only 10 short questions. Only 10 short questions from Unit 1. And other things are structured essays and essay type questions. So thoroughly you see Unit 1 and come properly, mainly see what are the reasons, why it's happening like that, why the radius is increasing, why radius are decreasing, right? How the ionization energy changes happens, how to draw these, what? The series, okay? How to draw hydrogen spectrum. Definitely there is a question from hydrogen spectrum, right? Definitely there are questions from the quantum numbers, okay? Especially the periodic trends. Periodic trends mean what? Do you know what periodic trends? No? How ionization energy changes, how what electronegativity changes, why that is greater than this, why is to compare the sizes of ions and anions, about the cathode rays, anode rays, how they deflect in mediums, right? And about that cathode ray tube, what we put there, how the rays are gone, and all these things will be asked here. So study well, because this is the first paper we are giving here, so we can assess how much you can get. So everyone who are coming physically, definitely they should participate this physical paper session, because it's free. We are not charging any amount from you, just you have to come and sit here. But please write it very seriously and bring some extra papers with you to write this exam. When you're coming, please bring the necessary things, pen, pencil, and papers, right? We will give the question paper. Finally, you have to attach that, and please write your mobile number as well, right? No, again, physical students may no need to write the mobile number. Online students, again, the other students, outsiders can write the mobile number, so we can send your answers photo, right? If you want, you can come and collect here. Nothing, you can get the photo of your answer sheet. We'll give you marks. We'll rank you. We'll see how you are going to perform it. So seriously do this exam. Already you have studied Unit 1. Or hereafter you have to study. Already have studied, no? So Unit 1 up to date. Everything should be okay. And especially the periodic table, right? What is S block, P block, D block, and especially electronic configurations, right? And now we will ask every single point, right? Whatever possible. Tricky questions also there. We'll see how we are going to handle. And there are calculation questions using E equals H nu. Can remember E equals H nu. Then there is there are formulas for E equal H nu. Another one, there is a formula for de Broglie wavelength, lambda equals H over P. All right. And those things will be questions. Right? So carefully do that part. We'll see how we are going to perform it. It'll be easy. It'll be easy. Right? Easy. But don't copy. Again, you will be under supervision. Cameras are there. Right? There's a camera here. එතනින් ඉඳන් එතනට focus වෙනවා. From behind also they are from here to here. So no blind spots here. Right? Or no. Everything is covered. You can go and see there. Right? Hari. Then all the best. Do it well. And if you haven't registered, please register in it. Those links are in our WhatsApp channel, right? Please tell your friends as well and call them also to write and check them. And remember and tell everyone, if you have registered only, you are eligible to sit for the exam. If you don't register, you are not eligible because we check those names and we take you in, right? So please, everyone get registered, fill the Google form and get registered. Right? And definitely tell your friends also. Right? With this, we'll wind up today's session. From next week onwards, 3:30 to 7 o'clock, we will have the session. Right? Okay. That's all for today, guys. Online students, everything clear, right? Okay. If you have any suggestions, you can put it in the chat box.